All right, so my name is Will Farr. I work for Western Weather Group. I'm an atmospheric scientist, bachelor's degree in atmospheric science from Utah, and a master's degree in environmental science with an emphasis on climate change. We've had a very long-standing relationship with the Sonoma County Wine Grape Commission. So some of you may have heard of us before. So a quick summary of what Western Weather Group does. We do weather instrumentation that's a little bit more high-tech than your Walmart weather station or what have you. The weather stations are designed to help mitigate frost and extreme heat. They send text message, email alerts. A lot of growers use them to calculate growing degree days, evapotranspiration, a lot of things that kind of come in handy, especially during crazy weather. And we tend to try to utilize the data when we do forecasts. And our Sonoma County weather station network has grown to 42, maybe 43 weather stations at this point, and we have many that we are trying to install as soon as it stops raining. This is a great day to talk about weather. Let's see, so we do ag weather forecasting throughout California, Hawaii, Louisiana, and Florida. One of the other big things that we do is we consult for a lot of big grape growers around the state. So I'm going to talk real quick about the weather data and forecasting. I know if some of you read the National Weather Service forecasts or have a weather app, a lot of times you look at it and say, oh, this thing's usually 5 degrees too warm on every night's minimum temperature. What we do is we kind of do the same thing, except we're looking at 4 or 5 different computer models, which are almost wrong 100% of the time. They tend to give the broad idea of what the weather pattern is doing, and then we take the data from the weather stations, and my job at Western Weather Group is to archive all of the computer models and recognize a similar setup to what's about to happen. So what we do is we go through and we look at every weather station's data, and then based off of that day, and then spit out a forecast that can be a little more helpful than the National Weather Services. If you do have or if you are receiving our forecasts, in the spring we do a frost forecast as well, where we take specific locations of the weather stations and forecast the minimum temperature for that night to try to give growers a heads up of what they might expect. We also put the data, growing or ag weather data, or ETO, powdery mildew stress, or powdery mildew stress points on the forecasts. And so we're following this year after year, and I believe Sonoma County is our longest standing relationship with the agriculture industry. I think we've been forecasting since the early 2000s out here, or mid 2000s. So after having all this data, we have a map on here that is showing about 42 of the weather stations. That after having 10 to 15 years of data out here, some weather stations are over 20, 25 years, we get a good idea of how weather affects agriculture out here. So first I'm going to talk about some common weather scenarios that you might have heard before. We've got resilient ridging, which is when you have a ridge of high pressure that just kind of hangs out for a long time. Persistent troughing patterns, Gulf of Alaska storm systems, atmospheric rivers, which are kind of a new hot topic in California meteorology. and inside sliders. First, resilient ridging. It's usually when you have a ridge of high pressure that sits over the West Coast for a very extended period of time. Often these can last 3 or 4 weeks, sometimes longer. It's pretty unusual to get one in the winter that lasts more than 2 weeks until last year. It's nicknamed the Triple R, the Ridiculously Resilient Ridge, and that is actually a technical term from the University of Washington. It's partially responsible for the drought. We had several months within that 2012 to 2015 range that where we had long extended periods during the wet season that resulted in much lower than average or much less than average precipitation. Let's see. So we'll start with persistent troughing patterns. They're usually prolonged active storm period or storm patterns with storms coming in every 2 to 4 days, a lot like February was for us this year. Jet stream becomes more wavy in nature, where you have kind of one broad trough sitting over the Northeast Pacific, and that just rotates individual storms inland. Those don't move very quickly. Tends to result in wetter and cooler than normal months because we get this pattern set up for 2 or 3 weeks. Gulf of Alaska storm systems, they're probably the most common thing that we experience. They usually originate in the Gulf of Alaska, or at least in the winter. They're the most common. They, like in this picture, you've got one very large storm system kind of right in the Gulf of Alaska, and it's rotating a smaller one down. This picture is just showing surface winds. It can move in certain parts because these storm systems tend to have a long lifetime and maturity. So you can get a warm front, kind of like what we're getting this morning, followed by a cold front, which we'll get this afternoon, and then, or maybe later in the morning. And they can also be accompanied by an atmospheric river. Usually, if that's the case, the atmospheric river moves inland before the Gulf of Alaska storm system moves inland. Which brings us to atmospheric rivers. They're usually very wet and mild. They typically provide Northern California with about 40% of the annual rainfall every year. Very long-lasting, usually. Sometimes they can be very narrow, which makes them a lot more difficult to forecast for. And warmer ocean temperatures and climate change may be increasing the frequency and their intensity. All right, inside sliders. These are the storm systems that probably Sonoma and Napa have the most experience with, I guess, because they're typically the ones that result in the Diablo winds, where you have a lot, like a really strong ridgeline wind speed, and once that ridgeline wind speed hits a certain threshold, the wind's downslope. So high fire danger when you see these in the fall. Now in the winter, when they come through, they typically bring a very cold air mass and not very much moisture, so they can result in a very cold period when the winds finally do die down. So you have lower dew points, cold air mass. That's when we typically see our frost during the winter and spring. All right, so now we're going to get more into the 2018 vintage year recap. Started off with a wet November, then one of the driest Decembers on record. We had 2 major atmospheric rivers that year. We had kind of a seesaw of temperatures between January and February, where we had temperatures near 80 degrees in January, or near 80 degrees at the end of January, and some places above 80 degrees at the beginning of February. And then we got one of those inside sliders that came through and brought record or near record cold temperatures. We had a wet March. The ski industry dubbed it the Miracle March because this is one of the only years where we had lower than or less than average precipitation, but the ski resorts were still open until July 4th. Then you had the April 6th atmospheric river, which was a very interesting event on its own. And then periods of milder weather during the summer months and short-lived heat waves. And then a dry harvest season. All right, seasonal rainfall. Some of these graphs might be difficult to see, just forewarning. So I'll try to explain them a little bit. Right here, I circled the two big atmospheric rivers that we had. One on January 5th or 6th, I believe, and then the other one on April 6th. And we'll touch on that on another slide. Then here are the maximum temperatures from October 1st through through September 30th. And that was, the two big stories here were just the late January and early February record warmth and probably like 2 or 3 short-lived but kind of excessively hot little heat waves. And that was, I think, early July, late June, and also in early August. For lows, this area circled here was February 18th, basically the second and third week of February, where we hit some places in the interior Sonoma County hit around 20 degrees, which is quite cold. December, we had a ridiculously resilient ridge set up. It kept temperatures about 5 degrees warmer than normal and low temperatures a few degrees cooler than normal because you didn't have the storm systems and the clouds that you typically see in December to kind of limit that diurnal temperature change. We had monthly rainfall totals of only about 0.05 to 1/4 of an inch. Cool nights and mild days produced slightly more chill hours through December than in previous years. I don't know if you guys use chill hours a lot, but we look at it for a wide variety of agriculture because we also work with orchards in the Central Valley. January atmospheric river. This one was kind of the drought buster or the mini drought buster. We finally had sea surface temperatures drop enough to get that ridiculously resilient ridge to kind of back off or break down. And this Gulf of Alaska storm system kind of cleared the way for a few more storm systems that directed an atmospheric river inland. You can kind of see that you get a train of storm systems right up here, and then you've got lots of moisture just kind of directed by all of them into the state. And we've noticed that these are occurring more frequently in the late winter and spring than they did 10 to 20 years ago. Let's see, most of interior Sonoma County got about 2.5 to 3.5 inches of rain in about a 36-hour period. And it brought the seasonal rainfall totals up from 47 to 68% of the year-to-date average. That's the average at that point in the year, which is pretty significant. Daily maximum temperatures in, I think this is January and February. Basically, at the end of January, that ridge somehow redeveloped and kind of sat over here. So this is the second dry spell of more than 30 days that we had in 2018 in the middle of the rainy season. So that's very unusual to get, 2 weeks of dry weather in the heart of the rainy season like February. And then this year, we had basically 2 whole months without any kind of significant rainfall. As far as temperature goes, this is just a graph of the maximum temperatures. 7 consecutive record highs from February 3rd to February 9th, and then a prolonged period with temperatures in the upper 70s from the end of January through mid-February. And then we had the mid to late February cold snap, where the ridge of high pressure moved enough offshore to make room for some weak storm systems to kind of dive south out of British Columbia, Canada, and southern Alaska, and they were very cold. We had a few nights of kind of gustier winds where you can kind of see right here is 20 degrees. It's 20 degrees, so I picked 5 or 6 weather stations that kind of represent each region of Sonoma. So there's one from kind of the Alexander Valley area, one in Dry Creek Valley, one Sebastopol, and then one in Sonoma. And then one coastal. Hirsch Vineyards, this one that's always going to look goofy, is more coastal. But what happened was you had kind of lows in the 40s and 50s, probably during the windier periods when you see the lows come up. And then when the winds died, we had low dew points that allowed temperatures to drop into the low to mid-20s for 4 or 5 days in a row. And that brings us to the Miracle March, which basically a persistent troughing pattern developed at the end of February and continued through the 3rd week of March. We had 18 days of observed rainfall during a 4-week stretch, which is kind of the opposite of what we were experiencing in February. Season totals jumped from about 52% on February 25th to 68% by March 26th. So we kind of played this catch-up game, get behind, catch up, although not fully catching up all the way. Kind of a 1 step forward, 2 steps back kind of approach. Monthly totals ranged from 5 to 8 inches for most interior locations of the county during that month. Then we had the April 6th atmospheric river. It was one of the strongest, actually it was the strongest atmospheric river that we have data for during the month of April. So we typically don't see atmospheric rivers during the month of April, but this one was actually one of the bigger ones. The ironic, or not ironic, but one of the weird things about it was that we had one on April 6th in 2017 as well. So it's actually looking like we're in another wet pattern going towards April 6th again this year. So maybe that's something we can just start to count on now. It produced 2 to 4 inches of rain in about a 24-hour period, which was at the time kind of a rainfall record. It brought season totals from 74%, or brought season totals from, can't remember what it was before. It drops after that 68%, but back up to 74% average. Summer recap, we had no excessively long heat waves, but there were a few days in there where we had temperatures well above 100 degrees. The theory is that strong upwelling off the coast cooled coastal temperatures, and that allowed more like onshore flow to kind of cool things off. So when interior California heats up real quick, it kind of wants to pull this cooler air inland from the ocean, cool things off. Growing degree days were around 5 to 10%, or down 5 to 10% relative to the previous 2 to 3 years, possibly because it was a cooler, wetter April and a pretty hot May and June. Kind of getting into the global climate change kind of thing. Temperature anomaly, we were about 1.5 degrees warmer than normal, at least in California and the West Coast. Sorry, I'm going to try and speed things up a little bit. So one of the big things that we're noticing with climate change that we've really been, that's been really prevalent over the last 5 to 10 years is, especially for California, kind of a big deal, is the jet stream modification. When the jet stream slows down, it starts to kind of coil up like a snake or like a slow meandering river. And when you get that, you have this big wavy kind of troughing pattern, ridging pattern along the west coast, and it's kind of luck of the draw. It's if you happen to have a ridge set up over you, you might be under it for 3 or 4 weeks. If you get a active storm pattern like we've had 2019, kind of the same thing. So what we can expect is kind of a consistent inconsistency. If it's high pressure, it's going to be consistent. It's not a definite, but a lot of times you'll have high pressure kind of sit there and you don't get anything for weeks, and then all of a sudden the floodgates unleash. We'll probably have wetter storms and more intense atmospheric rivers, lengthier dry spells within the rainy season, a higher risk for late season cold air outbreaks because of this troughing pattern that could potentially set up, like in 2018 in February. If that had happened a few weeks later, we might have been dealing with a few more issues. So I was going to touch on the 2019 vintage year, but I don't know if I'm going to have that much time. So deadliest and most destructive wildfire season on record. That may have impacted some grapes with smoke. 1.89 million acres burned. Grapes were affected. I've been working with Lake County on determining how and why. It turns out that we believe that grapes that were affected most were between 2,000 and 2,500 feet by wildfire smoke, mainly because of the inversions. You don't have transpiring grapes at night, so when the smoke settled the surface, there was no smoke effect really. But when it lifted during the mornings and the grapes were transpiring, they absorbed the smoke. Let's see here, 2019 rainy season. February was one of the top 3 wettest Februarys on record. We're living it right now. It's like it's coming back though. March we had a break, and then late March and early April look like they're going to be wet. And looking forward, this is kind of what to expect over the next 46 days. And it is showing Northern California is a little wetter than normal. We're in a weak El Nino, so that is kind of to be expected. Snowpack and reservoir status, we're doing pretty good. A lot of this water is trapped in the mountains right now as snow. We have a very low elevation snowpack, and that is going to result in a lot of runoff this year. And then kind of a summary. And that's what I got. Sorry to speed things up at the end there.
Thank you, Will. Are there any questions for Will? Anybody wants to look into the future and ask him questions about the weather patterns that we're going to be seeing? Any more so? Yeah, Scott.
Why do you think April's going to be wet?
Not necessarily thinking all of April is going to be wet. I'm leaning towards early April, mainly because the models say so. At this point, we just try to pick the best models and then figure out why they're saying it's wet. So if I look at a model and it's got a trough, like a really strong ridge over Baja and a really strong trough over the Pacific Northwest, I can say, okay, that looks like an atmospheric river coming in. But they don't tell you, hey, it's going to rain 18 inches in April or anything like that. But it does look like it dries out towards the 2nd and 4th week of April. The warmer summer is an El Nino thing. I didn't get to touch on El Nino very much. It's on one of the slides. But typically with a weak to moderate El Nino, we end up with warmer than average summers.
And are we looking at warmer summers with maybe that upwelling again to cool off those heat waves, or is it too early to tell that?
That would be the limiting factor this year. Kind of hopefully it does. The upwelling is still strong enough to take care of that. But when I looked at sea surface temperatures the other day, they were warming up a little bit off the west coast. So that's an indicator that we're not seeing as strong of upwelling.
Could you speak just quickly on sea temperatures, and has there been any trajectories that continue to rise, and is that affecting our long-term
Yep.
weather pattern?
Yeah, it is. It's a big impact. We do think there's a correlation between that resilient ridge and much warmer than average sea surface temperatures over the Gulf of Alaska. You get a ridge of high pressure just kind of set up over the warmer ocean water, and that's just kind of one of those things that we notice. We're trying to research, but it just so happens that when we get temperatures that are 2 to 3 or 4 degrees warmer than normal Celsius up there, that we end up in a drought. Yep.
Are you seeing any long-term trends in nighttime low temperatures being slightly warmer?
We are, and that could be a sea surface temperature thing. It kind of depends on what kind of pattern we're in, because we did have like 6 or 7 record lows last year. And then this February was the third coldest on record, but it was mainly because it was such an active storm pattern. But we did have, low snow elevations on 3 or 4 storms. But overnight lows don't necessarily correlate to a lot of that, because also with a warmer, drier climate in California, we have lower dew points and maybe even higher diurnal temperature changes. So you could have lows actually cooling off in some places, but closer to the coast, they are warming up.
Well, thank you, Will.